Hello, Internet. Welcome to Technical Interview Key Point Review. Today, very exciting. We're going to be talking about something really boring in real life, but really awesome in programming world. That is tree. So what is a tree? What the hell is a tree? Can you tell me what is a tree? I'll tell you, this is a tree. But that's not the true organ. That's the boring kind I talked about in real life. I mean, they're not boring. They're pretty amazing. Trees are really amazing in real life. Trust me. But that's not what we're gonna be talking about. But I'm gonna leave it there anyway, because it looks good. All right. So what is a tree? I'm gonna tell you. Tree is something like this. It's a node that has two other node that has two reference to another two node, which are their children. Am I telling you the truth? Do you know? No, I'm not. I'm not telling you the truth. A tree, this definitely is a tree. This is a tree. Don't mistaken. This is actually a tree. But let me ask you, is this a tree? This is also a tree. So what's the difference? This is called a binary tree. Binary tree. So when you walk into an interview and the interviewer tell you, hey, I have a tree. Can you solve this problem for me? The first thing to ask, are you giving me a binary tree? Because it's different. Everything in a binary tree is different. And that's the first thing you need to ask about is the binary tree. In the interview, most of the time it's a binary tree in interviews because it's again, interview has a length. There is only a period of time they can test you. If they test you something really difficult, it's not of their best interest because they want to know how you think and how you react to a certain kind of problem and what's your thinking process. That's what they are interested in. If they give you something you can't solve or it's something too complicated, then you probably just have the time to not solve it. I mean, there are value of it. You can solve it, and they can see how do you approach a very difficult question, but you're not gonna write code on a whiteboard in time and finish it, so they can evaluate it. They can take a photo and say, hey, this is guys, no, the code. You can take a look, and are we gonna hire this guy based on what he wrote? So if they test you something too difficult, they'll not be able to do that. So going to an interview, first thing first, ask if it's a binary tree. If it's a binary tree, are you good to go? No. No. What else do you need to ask? A binary tree also has a special kind, which is called a binary search tree. What is that? Binary search tree. So maybe I believe you know this. Every node, they have reference to other two nodes in a binary tree. They also have a data on there. So binary search tree is sorted in some sense. Everything to the left of one node, it's smaller. The value of it is smaller than the value of this node. And everything to the right of it, which I mean all of these nodes are to the right of this node. All of those nodes has a value bigger than the value on that node. And that's a binary search tree. And you need to check with your interviewer, are you giving me a binary search tree? Because if they're giving you a binary search tree, you can use binary search, which is a great algorithm that only takes log n time, which is awesome. You can find a element in 1,000 nodes in just 10 steps, right? 2 to the tens is 1024. So you can look up an element in 1,000 in just 10 searches in 10 steps. So it's awesome. So that's the second thing you need to ask. But Is that enough? So the interviewer tell you, hey, I'm giving you a binary search tree. What do you do next? Next, you need to check if this tree is full and complete. What is full and complete? It's a full and complete tree. So to explain what is full and complete, let's look at an example of what is not. This is an example of a not complete tree. So where are your children? Why are you not married? Where's your children? Right? By the way, what's this guy's name? To this guy. This guy is this guy's sibling. And this is parent. And these are his children. Left child, and right child. Those are his children. He is married, he has 2 children, so he's happy. But not this guy. If anyone in the tree, a node that's not married, I mean, he can be married, but he doesn't have children, then he's not happy. So a complete tree is every leaf node. This is a leaf node. Leaf node is, the node that sticks out as, what a tree does. A leaf sticks out and nothing attached to it anymore. And this leaf node, all of the leaf node, they're at the bottom of the tree. They're at the very bottom of the tree. And every node has exactly 2 children. Every non-leaf node, I should say, non-leaf node has exactly 2 children. And that's going to give you a full and complete tree. And one thing about tree is one thing you definitely need to know about tree is traversal. Traversal is how you traverse a tree. So let's make an example. Let's have an example. I'm gonna steal this example from Geek to Geek. I'm stealing. Hello, I'm stealing from you guys. I hope that's okay. So this example, this is a tree that's not complete, it's not full, but it's binary. And it's not binary search tree because this is assuming our data here is 1, here is 2, here is 3, here is 4, here is 5. And there are several ways to traverse this thing. You can go a lot of directions. But the 3 traversal you definitely need to know about is in order, which means imagine you're at the very last of the tree and you're going to the right. So in this example, you're gonna go this way. So in this example, you're gonna visit 4 first, and you go. Imagine you have a line that's going this way, it's sweeping this way. And the second one you see is a 2, and you go to the next one. The third one you see is 5, then 1, then 3. So in order traversal in our case here is 4, 2, 5, 1, 3. And post order is from bottom to the top, which in our example, imagine there's another line going that way, and you're gonna read this line first and this line second. We still have 2 lines that are going 2 directions, and you're gonna read whatever is on this line first, and on that line, what determines the order is the second line. So in this example, our first line across 4 and 5, and this one sweeping from left to right, and you have 4 and 5. And this line's over, then this line goes up, it comes here, and you got 2 and 3. and it sweeps up, and you have 1, and that's your post order traversal. You have 4, 5, 2, 3, 1, and after that, and the last kind of traversal you need to know about is pre-order. Where is my pen again? Pre-order. Pre-order, in my understanding, right? In my understanding, as you know nothing about tree, is let's draw this again. So we have this tree, and we have 1, 2, 3, 4, 5. Imagine you're exploring the whole thing, the tree here, and you're standing at the root, and the first thing you see is a 1 and recorded. Okay, I see a 1, then I go to see if I have a next node. Yes, and the next node is 2, and I see 2, and I go to the immediately left, and I see a 4, I recorded. All right, that's the end of it. Then I need to go back to 2, but I already have 2, so I don't write down 2. Then I see, is there another option? Yes, I have 5. So you write down 5, and you go back to your root. Then you see, is there another option? Yes, I have 3. And you see, do I have another option? No, you don't. So this is your pre-order traversal. It's kind of like you're exploring the whole tree, standing on the roots. All right, so those are the 3 kinds of traversal you definitely need to know about. And how do you make those? How do you write? How do you write a piece of code that can give you all of those traversals? My answer is very simple to you. The answer is 1 word. I counted for a moment there, so my math is not good, so don't judge. 1 word: recursion. Recursion. All right? Bring back our example. Bring back our example. Bring back our example. It's 1, 2, 3, 4, 5. All right? That's our example. And how do you get all the traversal with recursion? Easy. All right, for a in order, remember what is in order? In order is going from left to right. So a recursion, just imagine, like, what do you do what's a sub problem? You want to go from left to right, so what is the sub problem? So at this point, the sub problem is these. At this point, the sub problem is these. I mean, including that. So only you need to do is visit left first and record it, whatever you're doing, print it, doesn't matter. Then visit this, which you're on to now, visit this, which, I mean, if you're writing recursion, then you're writing root. Then visit right. The subproblem is this little tree right here. The subproblem is this there. So your base case, actually, to put a base case there, is if you don't have any children. If you don't have any children. So the idea is to visit your left child first, then visit yourself, then visit your right child. But bear in mind, if this is a method, since this is a recursion, you're not gonna write down that. You're gonna call in order. You're gonna call the self left, and here you're gonna call in order right. So you're gonna call the self left, and you're gonna visit yourself. Then you're gonna call this method again to the right, and that's how you get in order traversal. And how do you get post order? Post order, same idea, recursion. Same idea. What you need to do is you do a post order left, then post order right, then you visit self, which is root. Same idea. What is a pre-order? Pre-order you want to do first. You are exploring. So visit your root, which is self first. Then go to the left because we always want to go to left. I mean, depends on what kind of pre-order the interviewer is asking. And you visit left first, then right first. Just remember this left and right, those are your sub-problem. Those are not just a single node. So you're going to call the method you were writing again, it's a recursion. And you go to the left part and the right part of this tree. And there you have it, all three traversal explained vaguely, and how do you get them? And that's our lesson on tree. So to sum it up, you're gonna ask, is it a binary tree? Binary? So interviewer will tell you, hey dude, I have a tree. What can you do about it? And you're gonna ask first, is it binary? Is it binary search tree? Binary search tree? Is it? Is it complete? And what can I do with recursion? A tree is a perfect data structure for a lot of cases. You just want to use recursion because it's so easy to comprehend. It's just the data structure here. It's easily that you can find a subproblem in a tree. Anything that's a tree and there's a subproblem. It's really easy to comprehend. So definitely do a lot of practice on trees, and all the traversal online. There are a lot of practice. Be sure you can traverse. Doesn't matter what, the pre-order, in order, and whatever order the mutation of this traversal. Do them and practice. This is fundamental. This is really fundamental, and you need to know about it. And yeah. Thank you guys for watching, and don't forget to subscribe. It's gonna help me out a lot. And hit the like button. It's gonna help me as well. And hit the bell. My God, my drawing. Oh my God, I can't be an artist. Thank you very much. Don't forget to subscribe. Have a good night, ladies and gentlemen. Bye.